Welcome everybody to today's webinar. We've got an overview of HVAC grading, which is the ANSI RESNET ACCA 310 standard. This is the 2020 version that we'll be going through for today. As always, just a little bit of housekeeping. Today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find by either searching SPEAR on YouTube, or you can go directly to our website at eepartnership.org. We've made some changes over there. But under the news section, you'll find our resources page. On our resources page, you'll find a link to our channel. We have over 150 videos that have been uploaded to our channel, and you can use that for training as well in your office if you need to. Today's webinar is eligible for the ICC CEUs. You must be present for at least 3/4 of the presentation. Within about 72 hours of the presentation, you'll receive a course evaluation email from Kathy Lawrence. Please be sure and fill that out on the survey and get that back to her so you'll receive a course completion certificate, which contains the title and course ID number that you'll need when you're reporting your CEUs to ICC. Be sure and on the surveys, just give me your honest opinion. If we need to improve on something, please let me know. We'll get on that and take care of it. Lastly, the chat feature is open. Please use that to report any difficulties or questions that you may want to ask. I have the Q&A feature open as well, so you can use that to also post questions. We'll go through those as we go through today's presentation. It's not a real lengthy one. It probably should last about an hour. Anybody new here to SPEAR? What SPEAR does is we provide training, webinars, in-person, field training, as well as IECC test prep training. I can help out with someone that's looking to get certified. I can always help regarding questions of energy code, ASHRAE 90.1. We can help with plan reviewers, building officials, third-party inspectors, developers, architects, engineers, the ones that are actually looking to develop project in your area. I'm happy to help in any way that I can. We've also assisted several cities with the adoption of 2021, and now the 2024 is out. There are cities that are asking questions about whether they should wait on the 24 and do the 24 instead of the 21. We can help navigate those additional amendments. And help lessen the impact for the adoption in your city and get that rolled out successfully. My contact information, as always, will be at the end of this presentation. Please feel free to reach out to me with any questions, and feel free to share my information to anybody that would need our assistance. So SPEAR is a RIO. We're a nonprofit. We're member-based, 65 plus members across a wide selection of energy efficiency industries. We're focused on outreach, education, and collaboration of clean energy and saving energy consumption. So let's go ahead and get started today with the 310 standard. And so, as with all above code programs, our goal is to find ways to improve, or in this case, save on energy. The way we do this is through standardizing process. Or I'm sorry, before I get started here, we do have a guest today. Connor Dillon is on from BSI. He is with us today as a technical advisor. But Connor, if you can unmute yourself, if not, I can unmute you and you can introduce yourself.
Hey, everyone. Like Randy said, I'm Connor Dillon. I'm the quality manager for Building Science Institute, BSI. We're one of the two nationally recognized EPA Energy Star home certification organizations. We provide oversight and, as relevant to this, training on ANSI standards that we do quality management work on the rating companies. So in this case, I'm just here kind of as a guardrail, provide a little deeper insight if questions pop up, things like that.
Perfect. Thanks for that. I don't normally have a guest on, so thanks, Connor, for being here. I appreciate your help with this. So just a little thing that we go through. It's just, as I said a second ago and started with that, we're looking through standardization processes, established tolerance levels, and then, of course, with record keeping practices as well. Doing this creates consistency in energy ratings, efficiency labeling, such as ERI, HERS scores. This is doing us, we'll walk through the steps in just a minute, but kind of the background and development of this is establish, as we said, procedures, tolerances, and record keeping. It's intended to support consistency across, we've got a lot of different energy raters that are out there, energy auditors, energy inspectors, HVAC contractors. It's trying to help support consistency on installation and performance levels of HVAC. And then it's comprised of five non-invasive evaluation measures to ensure energy efficiency, the way it's installed. So one thing I wanted to bring up though before we get started with that is, according to the energy.gov, poorly installed HVAC systems is what we see a lot that's out there in code and above code program installations. It's estimated that duct leakage counts for about 67 to 100% of the significant duct leakage we see out there. Airflow issues, over 50% of the systems suffer from airflow issues, up to 15%. And some experience even higher issues than that. Refrigerant charge is undercharging occurs about 30 to 78% of the systems. Overcharging is usually found anywhere from 4 to 50% of all cases. And then approximately oversizing 90% of the AC and furnaces are improperly sized and installed. It's kind of tough with furnaces in Texas. We're a predominantly cooling climate, which means we need the airflow for cooling more than we need for furnaces. So we're allowed to oversize furnaces quite a bit to get the airflow needed, since it is a packaged system and it actually runs both conditioning for heating and cooling. So it's kind of tough to say, is that 90% part of the improper sized equipment? I mean, it may be sized correctly the way it should be, but I'm not sure how the energy.gov has done that evaluation for that part of it. So what this applies to single and two family residential AC and heat pumps up to 65,000 BTUs, and then furnaces up to 125,000 BTUs. This does not apply for multifamily that has one unit for all, one HVAC system for all units, including townhouses. They all have to have separate units. You can do townhouses or multifamily if all the units are separate for each building type or apartment or townhome that's in there as well. So the steps for this, and we'll get deeper into the weeds in just a second, but just a high level overview, it's 5 steps, and these things are, as we call them, non-invasive. The steps needed to grade HVAC is basically step one, you evaluate the design, and what we'll go through in a minute can really help your plan reviewers kind of, when I do city trainings, a lot of them ask, well, just give me the top 3 or the top 5 things that we need to look at when we're looking and reviewing Manual J. What are the top 5 things that we need to worry about? In other words, it is lengthy. I understand there's a lot of data in there. Some of it may or may not mean much to you. But what does it look like when I look at it, and where can I just throw a red flag up and say this isn't right? So you can use what you'll learn today in some evaluation in your plan reviews. And then step 2, we evaluate the total duct leakage. And then step 3, evaluation of the blower fan airflow. It's measured in different ways. We'll talk about that a little bit later. And then evaluation of the blower fan watt draw, how much power is being consumed per the CFM being pushed. And then, of course, step 5, evaluation of the refrigeration charge. So one thing that we look at, it's easier to try to look at it this way, and the way that it's in the standard is a workflow diagnostic testing flow chart. We start with design review, but as you can see with this, either the tolerances are met and you stop right there, or your tolerances are met, and if they are met, then you continue forward. If they're not met, then you stop at that stage. Corrections need to be made, design review needs to be readjusted, and then you move on to the next one. As you can see, anytime grade 3 is given during these steps, that pretty much pauses all of that. And when we say pause it, it's usually, if corrections can be made, then you can proceed after corrections are made and retest it to see if you've got a grade 1 or a grade 2 to move forward. If it continues to be grade 3 and it's not correctable, that there's not really a way that you'll be able to grade this HVAC system that's installed. And then some of them actually, just as we'll see a little bit later, you either get a grade 3 and it fails, or you're a grade 1. You don't really have a grade 2 option as well. So how am I doing so far, Connor?
Pretty good. I do want to really reiterate this slide. These tolerances have been, subject matter experts got together in the development of the standard and in different working groups to set these. So we have people from rating companies, from HVAC companies, from HVAC design organizations, so on and so forth, that all got together to figure this out. And yeah, if you don't, yeah, just like it says, if you don't get that grade one, grade two, or you're not within the tolerances, it's just you have to stop. You do not proceed with ANSI 310 grading of that system. That's not to say you can't continue to do ratings or anything like that, but you basically, if you can't fix it, then you're out of luck, right? So I can imagine you do a design review and the design review says you have to install a 3-ton system, and then you go out in the field and they put in a 5-ton for whatever reason because they had a spare one on the back of the truck. I don't know. Well, guess what? Technically, you have to stop right there because that system is so drastically oversized in my example that the tolerances are clearly not met in the field. So even though designed a 3-ton, they installed a 5-ton, and as soon as you get out in the field and you see that, you have to stop and it has to be corrected.
Yeah, that's a great point. Thank you. So step one, we'll just go through this. And as I said a second ago, if we've got plan reviewers on here, just kind of perk your ears up for just a minute. This can help you in your manual J verification. So even though they're not doing standard 310, this is kind of a top three, top four, top five that you can actually put into your practice to say, well, I know now something is wrong with the manual J. But as Connor just said a second ago, I mean, if the wrong system's installed per what they've told you is going to be installed, that's already a big red flag to begin with. But a large portion of this standard is all about design review. It's comparing the load calcs to the actual house size, and then items that are found during plan review. Um, First, we start out with architectural design, including verification of the plans and if there's any options that are actually there. So sometimes there'll be a bonus room that's on the second page, third page, or in the plans themselves, and you can find out what are the options that are there, what all needs to be included in number of occupants and size of home. All of those things are there. Then we move on to HVAC design, and I didn't list all of them here, but it includes, of course, manual J verification, the indoor outdoor design temperature verification, the number of occupants, the conditioned floor area, the window area, and then, of course, what type of mechanical ventilation is installed and how is that going to be designed. There are, and we'll see in just a second, there are some leniencies and some ranges that are there. And keep in mind, please, I don't want to confuse anybody. These are not code things I'm going through. If the code book says one thing, that's what you follow. If a program like this is being followed, then yes, there are some variances and or ranges that can be used that still means that it's proceedable and you can move on to the next step. It's not that it's wrong and has to be corrected. But it's again with plan reviewers, it's a good idea to keep this in mind of, if it's off slightly, but what you're looking at is that something that you're just going to not grant permit for that, and looking at it with the leniencies they have from this, it's more likely than that's not going to really stop your process from approving your permit request.
Hey, Randy,
So,
real quick.
yep, go ahead.
Brian Rodriguez, I see your hand is raised. I don't know if you have a question, but do use that Q&A feature if you need to. Okay.
Yeah, I don't see it on my end, but yeah, if you do, we can definitely do that for sure. Or type your question into the chat and or Q&A and we can answer it as we go through it. So, of course, as we said a second ago, a lot of it has to do with design review and, of course, types of ventilation and its design strategy. Is it exhaust only? Is it supply only? Is it balanced? How is this system being installed? Is it part of the system or is it a standalone system where it's not integrated into the system? And then, of course, equipment specs as well. We're looking at the efficiencies of that for SEER on the AC side of that, the AFUE for furnaces, and then, of course, the HSPF for heat pump on that part of it as well. That's all part of the manual J, just verifying what are the specs that we have.
Yep. And just, I don't know how Randy will get this out to people, but we have a resource that ACCA developed to do manual J reviews quickly that hit the highlights to see whether or not systems are within tolerances. And I think it was actually built and intended for code plan reviewers. So if
Perfect.
you can put that link in and to folks, that would be good.
Perfect. Yeah, I'll include that in our survey email. Thanks, Connor. And then, of course, and also continue on with our design review. This is where I say there are ranges that we can go by. So for load calculations, aka what's listed on the manual J, this standard allows for variation. So as we see here, is there a difference between the load calcs and the plans? And if you start looking at that, it'll allow up to 300 square feet less And of course, it'll also allow up to 100 square feet more. And so anything outside of those range, then you stop your process at step one and corrections need to be made. Either there's a bonus room that's showing up on the plans that they're going to use, but it's not listed on the load calcs, or it's the other way around. You just need to know whatever they're doing with this, and they're doing load calcs for that part of it. It needs to include all the options that are available and not just leave out what options are not being or what are being used. So, of course, in verifying square footage, as easy as it compares what's listed on the plans to what's listed on the reports. As you can see in this sample, we actually must verify the house size and the plans. So on this example here, I just kind of ballooned it out to the side. We're showing a house square feet on the right soft manual J, shows 1,637 square feet for both heating and cooling. So a range that we're looking for is anywhere from 1337 to 1737. Anything outside of that would be a pause, red flag there, a pause to get something corrected. And again, keep in mind, I'm not talking about just code houses. This is dealing with the standard. So please keep that in mind as we move through this. And then as we move on, we're still doing evaluation of design. Now we're moving into fenestrations. Um, what's listed on the plan, what's compared to in the report, looking at the manual J, looking at the builder's summary, and this is a page out of the builder's summary. If you're a city on here and you're a plan reviewer or permit tech and you're not asking for the building summary, you're missing a lot of key information and key efficiency items that should be listed and verified through the plan review. I do know they can get lengthy. I've heard that there are some cities that are requesting less paperwork for just the energy side of that because these reports can get lengthy. But maybe you let one come through that has all of them, and then you just pick and choose the ones that you need, and maybe going forward you say this is the pages that I need. I'm not sure how to handle that from the city side of it, but all this information here is important, especially when it comes to just manual J and manual S verification, is all cities should be doing. This theme should continue just through all of this is just make sure that you're verifying it from your side. So if, again, as we said, I'll stop saying it every single time, but if it's outside of the range, we're looking at windows square feet here, and we're looking at square footage on the plans. If the whole house is less than 500 square feet, then you have a range tolerance of 60 square feet or less, or 15 square feet or more. If you've got more than 500 square feet of glass on the window, then we convert that into a percentage less or a percentage more. So now you're looking at not less than 12% less and not more than 3% more. So again, that's that range, that variation of fenestrations that are on there. But I'm sure I'll keep saying it, but I'll try not to keep saying it over and over again. But if it's outside of that range, then you do not proceed to the next step.
Well, and let me step in for plan reviewers, right? Something that can be useful when you get the building summary report is to take look at the windows section on that building summary report and look at the manual J. I've done this before where people submitted the documentations for review, and I noticed that the windows on the front of the house were very different between what the rater provided and what the HVAC contractor provided with the manual J. And that was a way for me to find, hey, who is wrong here? Why are they wrong, and what's going on? And so in this case, I think what wound up happening was the builder provided the correct plan set to the rater, but provided the wrong plan set, or maybe the HVAC contractor just duplicated a project, I think is what it wound up happening. And so they had used a different plan that was same square footage, but it had different window orientations and sizes and stuff. And so there was some conflict between the documentation, and we were able to figure out why the system was oversized was because of what happened there. So when you get these documents, there's ways for you all to check it and just provide some consistency because HVAC contractors don't always talk to raters and vice versa. And sometimes builders make mistakes, and it is what it is. So let's just try and make sure homes are built right at the end of the day, right?
Yeah, absolutely. Perfectly said. But I do know, I mean, I still get calls of building officials or a plan reviewer that calls me or sends me an email and says, "Well, here's what I get. I get one wall for the entire square feet or length of the house. It's just one wall listing all the windows. I do understand that doing a res check can sometimes, now that it's the newer versions of those things, it's asking for you to break everything out into walls. So you'll build a window and then you'll assign each window to each wall. That way it actually has the orientation. But I just kind of have to laugh it off. There are still res checks that come in for plan review, and it's just listing front wall, and it has every single window listed on square footage size on just the front wall, and they're hoping to get that through plan review. That in my opinion should never be allowed.
Oh,
Um,
100%.
yeah,
100%.
it's just those little things that we like having this job to hear these stories. But evaluation of the design, again, keep in mind this is not code. This is talking about if you're doing a rating, you're doing HVAC design or 310 standard. You can't do a block load. It's got to be a room by room load calculation. So instead of doing a whole house load, which is usually kind of what's done a lot for code houses, you're comparing a basically loads that are calculated for every single room. So a block load is not allowed for this. And then, of course, north must be identified on the orientation. You need to know which way this house is facing. Same for multifamily, where the orientation must match the way that each unit is facing. It cannot be just a generic, it always faces north direction. In other words, different load calculations must be done for each different orientation. So that's into the game there. And it should always be, in my opinion, even for code stuff, this should always be the same. We should always have the orientation correct with the way the front of the house is. I know there were some questions in the back, and when we had townhomes that the end units have doors that face the side because that's how you enter into them. It's the way the front of the building is facing, not the front of the door facing, if that makes sense. So that's the way I always kind of split it up when we did inspections and ratings in the field, as we had to understand it's the front of the building, not the front of the door. So was that correct, Connor? Is that kind of how you see it as well?
Yeah, that's the way that we train folks and how my experience it is industry wide on the rating side. It's kind of what's the perspective from the road, right? Irregardless of where the front door is, like the entryway, it's where you're standing looking at the dwelling unit.
Correct. And then, of course, continue on with the design review. We're looking at design temps. First, we're looking at indoor design conditions. So this indoor design condition must be 75 for cooling with 50% relative humidity and then 70 degrees for heating. This is slightly different than what code allows, which is 72 for heating maximum and 75 for cooling maximum, or minimum, I should say. And then, but for HVAC grading, it kind of allows you to design 70 degrees for heating as well. So this changes slightly for that part of it. This is probably not something that you'll see in your res check or plan reviews. That if they're following code, they need to follow the code standard, which is 72 and 75. Just for the HVAC design, which you'll not be able to, the 310 standard, you may not see that in your permit request documents, but it does, just to let you know, there is a difference between those two standards as well. And then outdoor design conditions, basically you're basing it off tables 1A or 1B that's in Manual J. And also in the ACCA Standard, it is the 310. All these tables are listed in the standard as well. In this example, I just picked out DFW. The outdoor design conditions for DFW is 99% of the time the outdoor temperature is above 24 degrees, and 1% of the time the outdoor temperature is below 98 degrees. I'm sorry. Yeah. No, above 98 degrees. My bad. This method is the same as when it comes to IECC requirements. And so a lot of times these numbers, HVAC guys might twist this a little bit and move those numbers to get a bigger size equipment. Judging by IECC requirements, you need to follow these ACCA tables. You need to look at that part of it and see that it's following the 99 and 1% rule for outdoor design conditions. And then, of course, the internal gains, aka the number of people we have and what this being designed for. The number of occupants are calculated as the number of bedrooms plus one, assuming the primary bedroom has two. There is an allowance for this standard of plus or minus two. Energy Star follows the same logic. It's a plus or minus two. So if you do have, and this is where it can kind of overlap, if you have a builder that's doing Energy Star as a compliance pathway in lieu of code, they're doing in that range for Energy Star, which is plus or minus. So what should and can be included and can be considered is full-time occupants, but not guests. In other words, we can't really design for 15 plus occupants to oversize the equipment for a July 4th party. But what can be included is generational occupants, such as you've got a mother-in-law suite, you've got a secondary primary bedroom that could have two in it. So if you have a three-bedroom design, it's okay to at least see one or as high as five for occupants or number of, excuse me, number of occupants when it's being designed. So that's just the internal gains. We're little heaters that are inside of rooms that have to be accommodated for when it comes to conditioning. So we're included in there to say that's what we need to overcome when it comes to conditioning is the number of people that it's being designed for. There is also variances on wall insulation. So load calc, R value can vary from plus or minus R2, as we see here. Again, keep in mind, this is not what code says. This is what the standard says. So if the actual wall is R19, but we're seeing a range of 17 to 21, it's within tolerance and is acceptable. And then attics, kind of the same thing. We have an allowance of plus or minus R4. And if you look at, again, we go back to what I said a second ago. If you have Energy Star as a compliance path, there are trade-offs. So even though the requirement for your climate zone is R38 and the Energy Star is being used as a pathway, then they could be trading off attic insulation for something else. So you'll lower the attic insulation for more efficient HVAC systems or better windows. There are ways to trade that off. So this allowance kind of allows a plus or minus R4 in that part of it. And then total duct leakage is step two. So we've gone through that design review and now we've just now got into step two. So total duct leakage is required for HVAC grading. Leakage to outside is not allowed. If you're not familiar with that phrase, LTO and TDL is total duct leakage is just using a duct tester and you're just doing the whole system either at pre-drywall or at a final. And then leakage to outside is when you're actually doing a blower door in conjunction with a duct tester and you're actually coming up with the number of what's leaking outside of the envelope. It used to be acceptable by code. It's no longer acceptable by code, but RESNET as a HERS and other standards that are out there do still allow for leakage to outside. But when you're specifically doing the HVAC grading 310 standard, you have to do a total duct leakage. We're worried about the system as a whole and what's leaking, not what's just leaking to the outside. But as we see here for grade one on the duct leakage, you can do it at rough in and or final. And now, if you're not familiar with the 24 code yet, there actually is a table that brings up the number of returns, changes the testing requirement that's needed for duct leakage. And so they've kind of, it's the same kind of thing here. So if you're doing rough in, it's less than 3 returns, then you're plus or minus, or you're less than or equal to 4 CFM per 100 square feet or 40 CFM total. And then rough in, if more than 3 returns, and it's moved up to 6 or 60. And then at the final, we're looking at kind of the same thing. Less than 3, you've got 8 and 8 or 80 tops. And then final, if it's more than 3, then you've got 12 or 120 tops per system. So again, that's not code requirements there. That's just the standard requirements. But also, if you have systems that are fully encapsulated in a foam house and everything's within the conditioned space, well, everything minus up to 10 feet of ductwork is inside the conditioned space, then the standard doesn't require it to be tested. In the 2021 and moving forward, then it is still code required to be tested, even if it's all in conditioned space. But if you're in a system, an area that's 18 or 12 or 15, then it doesn't have to be tested. So this is also excluding that as long as 90% of everything is inside the conditioned space.
So I'd like to jump in here real quick with a couple of
Yep.
comments to elaborate on some things. When it comes to these total duct leakage values, raters that are going out and doing these tests, I believe they're now required that the air handler, the inside air handler, has to be installed. So they can't test supply side and then the return side. They have to test the entire system. So the equipment actually has to be installed at the time that they do the test. So it used to be you could just do supply side and then return side and then call it a day. Now the system does actually have to be installed. This is something that you can find in a separate ANSI standard, which is ANSI 380. They clarified that, I think, a couple years ago. So there's that. The other thing is these thresholds. If y'all are familiar with the total duct leakage requirements from the IECC, you can see that 12% final for three or more returns is kind of excessive, right? In
Mm-hmm.
my opinion.
Mm-hmm.
And so the threshold is 4% commonly, right? So something I have to really reiterate to folks is if you want 4% to be the threshold, then you need to make sure that the raters are actually doing that. Okay, so if a rater is pursuing Energy Star certification as a compliance path, technically that 4% option does not layer onto this, right?
Correct.
Energy
Yep.
Star doesn't look at that. They just say, here's our program, meet the program, you're good to go. Unless the rater has within their signed scope of work under a contract with the builder for actual code, like IECC code compliance threshold requirements, they're not technically required to hold that builder to that standard. So, just to, not to throw a wrench into anyone's rating business, but if you want people to do 4% total duct leakage, irregardless of their compliance path, whether it's one of the normal ones in the IECC, whether you're in Texas and you're doing the Energy Star compliance path or you're doing the HB 3215, you need to make that explicitly clear with an addendum or something like that. Because I have seen it where homes pursue Energy Star for certification and they're not doing 4% total duct leakage because they're doing Energy Star, and Energy Star doesn't have 4%. They have 8% or 12%, so on and so forth. So just a note, be careful about it depending on the compliance path that someone's pursuing.
Yeah, it's a great point. And then the last thing I'll say on that part of it is when we say number of returns, it's actual returns that are ducted back to the return plenum, not jump ducts, not pass-throughs, nothing like that. It's got to be a dedicated return. It could go to a return plenum that ends up pushing its way back to the return, but it's got to be connected to the system. It can't just be jumpers or pass-throughs. So, and then with grade two, we can see the limits are actually varying when the test is done. Again, it's rough or final. And as we just see, I'm not going to go through all of that, but it raises those scores. And as Connor just said a second ago, that's where it can get a little tricky, is that they're following this standard because they're doing Energy Star plus HVAC grading, and it gives them more leniency on leakage for duct leakage, but it's not really adhering to that code requirement of 4 CFM per 100 square feet. So I know that sometimes at this point it now gets complicated of, well, I don't even know what to look for anymore because it's jumping around with different allowances for leakage. So it's kind of why we are in the industry that we're in for energy. It gets complicated really fast. But as you see here, it goes from a 6 or 60 all the way up to a 14 or 140 CFM per system. So that's what we're doing here. And as we keep in mind, if you're looking at code, and this was always tough for me when I did training for inspectors, is we're doing two system duct testing and one's failing miserably, but one's passing considerably at a very low leakage rate. For code, it's leakage per the whole house, not per system. So it's if you're looking at 4 CFM per 100 square feet, as long as both of those numbers add up to 4 CFM or less, as a whole, the house passes. Is that acceptable to leave it that way? No. If it's really leaking on one of the systems, it should be corrected because that leads to imbalances and all these different things that we go down rabbit holes with all the time. But when you're doing HVAC grading, it's specific to every single unit independently. We're not going to crossed that threshold of adding these numbers and averaging them and saying that we're still getting there. That's not how we're going to do this standard. And then, of course, with grade 3, that basically just means you're exceeding the limits. And if you're exceeding the limits, then you just basically stop the procedure there. You don't move to the next step. The evaluation now fails and corrections must be made. And as we said earlier, you can make those corrections and then you can proceed on with those steps as well. But really, those testings should be done all over again to restart that whole thing. But I wouldn't have to go back through design review as long as that passed step 1, then you're just stuck at step 2. And then if duct tests are failing, then you're going to get that corrected and you're going to start over with step 2 and move forward. And then of course it's we'll bring this up. This is not a step in the system. I like to bring this up because it's good to discuss it every time. But when you're looking at manual J, manual S, you're looking at load calcs. Someone's got to put a predictive blower door results in order to get manual J's to come out correctly. For new construction, the standard of air sealing technique should be using an average or a semi-tight. If you've got high performance homes like Energy Star or above code program, then maybe you could use tight. Just keep in mind that if the builder or homeowner wants to oversize the equipment, they could choose a semi-leaky or leaky and gain more tonnage. That, in my opinion, with new construction, semi-leaky or leaky should not be used. Even if you're on the 2015 code and you think that's an old code, you still have an air changes per hour that needs to be met. Air sealing measures need to be applied. I don't think anyone should be in new construction using anything higher than average. Average should be the top in new construction because what you can do is as I just said, you can raise the tonnage slightly, even a half ton, if you go with a leaky instead of an average tightness of a home. So it's always good to bring that up. But there's an allowance in the standard that allows for a plus or minus 2 ACH. In my opinion, as an energy rater, that's huge, but I understand the allowance for that part of it. And then blower, and then we move on to step 3. Step 3 is blower fan airflow verification. So for systems that pass the leakage duct test, once you've moved past step 2, then you get into the blower airflow. And then, of course, with this, there's different ways that you can do it. As long as if it's inside a conditioned space, 100% or 90%, and it's excluded from being tested, of course, then you've got a grade 1 and you move on from that. But you can test airflow in different means. So grade 1, you're allowed to measure airflow by pressure matching, which is where you use a duct tester and you match the system's fan pressure, and you get a fan flow rate. And then you can use the flow grid. We'll see a picture of that on the next slide, or you use a flow hood, or you can use the OEM static tables where you just take static pressure readings and then you look at the static pressure or static tables from the manufacturer and you're able to discern the airflow from that system as well. For systems that pass the grade 2, it kind of limits you now. You drop off with one of them. You can no longer do flow hood testing. If you had a grade 2 on duct test tightness. If you're a grade 2 with that, you can move to the next step, but you can no longer do flow hood testing. That's where you actually have a hooded unit that you can put it over all the vents, the supply vents and the return grills, and you can get an airflow at each termination or input point for returns. And then you add all that up and try to get a fan flow. But since there's something wrong with leaking somewhere in the system, it excludes flow hood testing and it actually leaves you only pressure matching a flow grid, which is what we see here in the picture, or you can still use the OEM static tables. The flow grid actually is really cool. It's wireless, Bluetooth connected, and you actually can replace the filter with this unit. You pop in the right size. You put that piece in the middle, which is a powered unit that you turn on, and then it actually communicates with your manometers. And so this is made by TEC, the Energy Conservatory, and that is actually gets you the airflow reading. In my opinion, this is kind of probably the most accurate way to do it. That kit is not cheap. I understand it. There are different ways that you can do it that may be less expensive for the stuff that you do have. Let's see. I think there's
Here,
a
I can answer this.
question. Yeah, okay, go
Yeah.
ahead.
So the question in the Q&A feature, which again I recommend everyone uses, It says, who is capable of doing this grading either by certification or other?
Great
So
question.
technically, yeah, that's fantastic. You do need to know who's capable of doing this. So there are two predominant rating systems in the United States that, excluding California, that you can get certifications to do this. The first is through ResNet. Everyone's heard of them. And specifically, you should be looking at someone who is a ResNet rating field inspector or a ResNet HERS rater. And not only that, those are just prerequisites. They are also required to go through ANSI 310 training delivered by ResNet. And then they are required to go through two field trainings um, uh, on the ANSI 310 process itself. So actually going out and doing, the flow grid method, getting that fan airflow, so on and so forth. So that's one. The other is with BSI, and obviously I'm biased here. I think we're better, but again, I'm biased. Ignore me if you need to. And we have a very similar structure in the sense of we provide the training, and then we have field evaluation requirements as well. And so you should be looking at someone in our system. We call them field verifiers or full verifiers, right? BSI verifiers. Those are the credentials you should be looking for. And you should, if you have an issue finding this at all, you can always go to ResNet and BSI both have registries that are publicly available to find certifications. So you can go look to see if someone carries a certain certification as a resident RFI or HERS rater or as a BSI field verifier or full verifier. Um, I don't think ResNet specifies whether or not the people have gone through ANSI 310 or not, so you may have to contact their QA provider to verify it. Um, but yeah, that's the general lowdown. Technically, though, it is an ANSI standard, right? So if someone is otherwise qualified, so I can think of like building analyst professionals from BPI or BPI energy auditors. This is an ANSI standard, so it's publicly available. They could, in theory, go through the process of performing the assessment, but they're not, they won't be able to put it into a rating software like House Rater or Ecotrope, RimRate, or so on. They'll just do the assessment. So it's not quite the same thing. If you want the full capabilities, you have to work with BSI or ResNet qualified people.
Yeah, that's a great question. I should have included that in the beginning of the webinar. But I can't remember. I know TEC also has certifications for taking their training for duct
Mhm.
blaster and blower door. I wonder if they have one for this standard.
Yeah, I don't know. I'd have to go back and look through their stuff. TEC does have online training that's free. So it is actually quite useful. I do appreciate that. RetroTech also has training. I can't remember if it's paid for or free. Um, but I would be hesitant to I would be hesitant to just say go through this training with a manufacturer, irregardless of whatever other credential you might have,
Yeah, I
and
agree.
then do it. At the same time, right? It's just one of those things where um, if you're the code official, right? I mean, if you're the code official and you determine that someone can do HVAC grading and they're, a BPI energy auditor, as long as they go through the procedures, you know, I'm I might disagree with you, but it's your city, right? So I'll leave it at that.
Yeah, no, great point. And again, great question. I appreciate the question for that. Thank you. And then, of course, continue on with the blower airflow testing. We've got variances and tolerances that we can do based on the total CFM of design and comparing it to the measured airflow. You're able to assign a grade to that part of it and then move on to the next step. The system should be running for at least 10 minutes to ramp up to full speed before performing the test. Of course, that can vary from manufacturer or unit type. But as we see here, grade 1 is anywhere between plus or minus 15% difference. Grade 2 is anywhere from plus or minus 25% difference. And then anything over 25 is grade 3. And as we said before, and I said I wouldn't keep saying it, but if we hit grade 3 with this, then we pause here and we have corrections made um, to get to that next step for that next one. Yeah, I think I have this on another slide, but to bring it up now, and it's a good point to bring it up here, is looking at fan flow. And I'll go down a rabbit hole for just a minute, just because this comes full circle back to what we always have webinars for is when you look at it and you're doing the testing and you say, well, we're doing a grading system of grade 1, grade 2, grade 3. How much is actually in a CFM airflow of what's actually been totally designed? So if I have a 4-ton system at 1600 CFM, if I now did the measurements by whatever means I do that and it's different, how and why is it different? Um, to go down that rabbit hole of this is where we talk about the previous webinar we had and webinars before this is proper duct installation. If you've got kinks, sharp bends, crushes, compromising of ductwork, the system's trying to pull in as much as it's pushing out. If it can't push it out because of crushed ductwork, or if it can't return that amount of airflow back to the system, whatever's coming in the back end is going to go out the front end. So it's not going to magically push more air. In other words, if it's 1600 CFM I'm needing and I only get 1450, it's not now going to push 1600 in front of it and now, well, we're still getting 16 on the supply, but only 14. You could do that if you've got a lot of leakage on one side or the other. But if the system was completely airtight and you're just transferring air around, but you have friction loss in the ductwork because of improper installation, you now have a defect in airflow. And this is where now when we're grading these and testing it, we're basically getting a report card of the system. This is running poorly because we've noticed evidence of crushed ductwork, kinks. If you have leaky ductwork, then it's not going to continue on this process of grading. But installation and proper installation of ductwork isn't part of this standard, but you look at the results of what happens when those things are improperly installed. Hope that made sense. That's kind of the rabbit hole I wanted to go down with. But I mean, do you agree, Connor? That's kind of what we're looking at here is grading this system by giving it a report card, judging the full installation, including ducts that are installed.
Yeah, I mean, this is where you get obviously total duct leakage is an aspect to it, and there's a reason why. If you're wondering why external static pressure is allowed to be used for the blower airflow, right, from the OEM static pressure table, that's because you're able to see whether or not there's back pressure in the system from poor duct designs where it's been kinked and whatnot, and you get this increased back pressure against the coil. And so you're able to see essentially whether or not it's able to actually deliver that airflow, right? And at the end of the day, that's what we want. We want a system that's properly designed, properly sized, that's been installed right, paired with a duct system that's been installed right. So that way the occupants in that house can be cool in the summer and warm in the winter, right? And excluding the 1% winter storm Uri situations, they're gonna be safe and comfortable. And that's where it all ties together. It is a whole system, and obviously the next step that we get into, well, not the watt drop, but the step after that is also very critical.
Yep. Yep. Agreed. So the next step as we get into this is step 4. It's blower watt draw, which is basically you can use different methods of testing and verification of that. We have a plug-in meter like what's called a kilowatt. So we don't, in this climate zone in Texas, we don't see units that can be plugged and unplugged. In other parts of the country, we may see that. It's an air handler system or just the air handler for a furnace. It has a pigtail on it. It's plugged into an outlet. Those things can be pulled out and put a kilowatt meter put in. You plug the system into it. You're able to run the watt draw, and you can measure the wattage through that. That's a real easy. You're actually just measuring power and converting all that, but it's real easy to be able to do that. We don't have that availability usually here in Texas or Oklahoma. So a clamp meter like what you see in this picture here, this is normally what's used, but unfortunately we'll have to actually locate the right wire, which is basically meaning you're taking the case cover off. Some HVAC guys don't like third parties to do that because we're not licensed HVAC technicians for the most part, but it's part of the standard that we have to follow. Or you can also turn off everything in the house except the HVAC breaker, and then you actually do a reading of the digital meter or analog meter that's on the outside. So that I know there's third parties on here that do that. That's how they do that, is because it's less intrusive, it's easier to do. The problem is if anybody's done energy inspections and or just building inspections, The chances of you being the only person in that house for at least 30 minutes is slim to none. So if somebody comes in and, well, why is the lights turned off? And you're either outside or up in the attic, well, they're going to go find the breakers that are off and turn them all back on. And now you've got to start this test over again. So it's tough to be able to get whatever method you want to use. It's tough to get that done if unless you just lock everyone out of the house. But a lot of the painters and the builders, they all have keys to the home, and if they find out it's locked, they'll just reopen that house. And of course, as we said a second ago, you can do a meter test as well. But watt draw is calculated by taking the total number of watts and then divided it by the CFM that's recorded from the airflow test we saw in the previous step. So if the watts to CFM is less than 0.45, then it's grade 1. If it's 0.45 to 0.58, it's grade 2. Anything over 0.58 is now grade 3. And as I said a second ago, and I'll reiterate it again, this is a light bulb moment. This is why would watts be higher? Why would we get a difference in range of how much power is being drawn? If you go full circle, it's ductwork compromises. It's like thinking about when you take blood pressure and you have a high blood pressure, it's because you've got possibly you got some sort of blockage somewhere in the system and or constriction of the blood flow. Same thing with ducts. You've got a constriction because it's crushed, it's kinked, it's got sharp bends to it. It's just not following manufacturer's installation instructions. Therefore, and I know I've harped on it in many, many webinars before, and I usually do it with my in-person presentations, is when you go in the attic and you just see poorly installed ductwork, that's a big red flag to me. Somebody's got to correct this. Otherwise, more power consumption, you're increasing the wear and tear on the system itself for the longevity of the system. All of these things come back full circle, and that's kind of why we talked about in the beginning, but HVAC grading was kind of put together as a standard. Let's do a report card of the system and how it's installed, and let's see if it meets manufacturer's installation. If it doesn't, then one of these 5 steps will fail, and then corrections will need to be made.
And I just want to pop in here to reference something on the previous slide about the test methods. There are
Mm-hmm.
people that say, "Hey, yeah, just pull off the panel facing and just connect directly there." I'm of the opinion that that's stupid for non-licensed electricians to do because I think it's a great way to induce a house fire if you have an ignorant person touching things that they don't know how to do. So if I was a code official, a general recommendation would be to make it clear that if you're performing ANSI 310 and this is your preferred test method for the blower watt draw, you're not allowed to do that unless you're a licensed electrician in your state. And if you don't have licensing requirements for electricians, um, then you got to do something else. They have alternatives. They're not required to use that one method. You have other options. So that's a personal bias I have. I've heard stories growing up of where people in construction accidentally touched a live wire, passed away and things like that. And the last thing we need is an inspector to go in Friday afternoon, last person there, um, touch a wire, drop dead, and no one finds them until Monday morning, right? So general recommendation I have is don't do that. A lot of the people that say to do it is because they're worried about confined spaces in attics, but you're also dealing with 6 to 812 slopes, and you have pretty good ceiling heights in a lot of homes these days. So I think that's kind of a stupid excuse. I think it's just people being lazy personally. So, that's a little tangent bias that I have there. Do something else. If you're able to do the plug-in, do the plug-in. Otherwise, I mean, heck, there's nothing stopping people from coordinating a electrician going out when they're wiring and setting stuff up and stopping that rater saying, "Hey, can you real quick pull this off and do this test for me?" There's nothing stopping that from happening, right? And I'd rather have a licensed electrician mess with my panel box. I don't even touch my own in my own house.
Yeah, I agree, and that's. I mean, I was around when 310 was first introduced, and we did a lot of field testing to find out what was the easiest method to do. And that easiest method to do is just read the digital meter. But you have to, in my opinion, schedule with the builder and say, look, if I'm doing your 310 standard, I need everyone out of the house. I can't have painters there. I can't have people using lights. I need everything to be off. And it's just a matter of just proactively scheduling it correctly with the builder, and that way you can have ease of use to the home without other people involved.
Well, and
So
this goes to fundamentally the workflow of the standard. When it was being developed, a lot of the people were basically saying you're going to be adding in these additional tasks, right? So a rater would, at a minimum, already be doing the total duct leakage. So in the field, they're adding in that fan airflow, the fan watt draw, and checking the refrigerant. And so what their solution was that is basically while you're doing all these other tests, go ahead and just, walk around the house and do it all to try and reduce the load time because they were saying it was going to take anywhere from 45 minutes to an hour for these additional tests, but they were able to take it down to an extra 30 minutes by having that fan airflow test running because they've got that Bluetooth gauge connection and then going and checking the meter and so on and so forth, right? So, I think you're right. You really do need to be proactive and say, if I'm doing 310, when I get out there to do 310, no one else is going to be out there. Lock the doors, whatever you need to do, so that way you can get it done safely without, you know, losing your mind, really.
yeah, or even posting a sign on the door that says testing in progress. Please do not open door. Something like that. Yeah,
Yeah, exactly.
agreed. All right, and then the last step we have here, the final step, is refrigerant charge verification. There again are different ways that you can do this. One is you have onboard diagnostics. So if someone has a lot of automation that's set up on their system, if you have an onboard diagnostics or what's also an independent verification, it's considered grade one and passes the final step. So if I have an onboard diagnostics, it can read subcooling and superheat. There's as you see as the bottom, there's subcooling between plus or minus 3 degrees, superheats plus or minus 5 degrees. So if you have onboard diagnostics that's already given you that, then you don't have to do all of this, and it's already achieves a grade one. But there are other non-invasive temperature measurements or weigh-in method as well, and we'll see that on the next slide. So with this, you've got non-invasive temperature methods. There are kits now that are out there that you basically have all these different meters that are wireless and Bluetooth reading that you can attach to because we'll need for the temperature readings, we're going to need to measure return dry bulb, the wet bulb at the condenser. We need to have the entering dry bulb, and then of course both the suction and liquid line temperatures as well are needed to be measured. And all these are done at normalized blower fan CFM. So you have all these things on here that's doing the reading as the system's running. And as Connor said, when it first came out, the first thing we as raters looked at and said, this is going to take me an hour and a half on every single house, and I don't have the time. But if you put this in your process, and I know there are people on here that do it on a daily basis, and they've now streamlined their process, and you're able to get this done in a half hour or less on most houses. So once you determine what metering device that's being used, either TXV or piston and capillary, then you know which table to use. And again, in the standard, the tables are there. So as we see here, and this is now different than any other step, is there's not a grade two option. It either passes or fails. So if you're using a TXV like at the bottom, then you're basically you're greater than -6 degrees or you're equal to or less than 6 degrees for grade three. So if that difference is there, then basically that means it fails if you're grade three. So there's ways of doing that part of it. There is some I would say research, but basically you just have to do some investigative searching first to find out what type of system it is, and then of course what type of metering device they have. Majority of everything we're going to do now is TXV and going forward. But this is if you're doing one that's an older system as well. And then, of course, the last method we have is the weigh-in method. So the rater's using data from HVAC Startup Tech. So documentation that's included, what we need from all of this is total weight added and or removed by the tech. If you're not familiar with HVAC and how those things are done, when the condenser shows up new, 9.5 times out of 10, the condenser has refrigerant in it and the valves are closed. Once the systems are installed, the line set is installed, then you open the valve and the system, as long as it meets the line length of the line set, the refrigerant that's in the condenser should be close, if not accurate, on the installation. But again, this is why we do a report card of the system is if the line set is smaller or not as long, or if the line set is too long or longer than the refrigerant that's in the system, well, now when those valves are open, you're either short or overcharged on the system, and that has to be tested and verified. So total weight added in and or removed by the tech needs to be documented. A photo of the scale that's the technician sitting at the system, as we see in this illustration, is they've taken a picture of the scale and with it being attached to the system. And hopefully you can read the scale of what it says. That's really what it needs to be. It also must be time stamped and geo-tagged for its location to verify that they are at the right house. I do understand there are variances in geotag. So it could be up to like 50 feet. So it could technically be showing you the next house over. But as long as it's in that neighborhood and geotagged for that, that's where you're meeting the requirements. The total length of the line set, the liquid line, and any adjustments also have to be documented, including the full length of the line. And then, of course, what's the outside diameter of the liquid line? So different refrigerants are now coming out that are making the liquid lines change in size. So that has to be documented. Then, of course, weight of factory refrigerant charge. So what was in the condenser to begin with, and then the calculated total charge to calculated deviation. So to achieve a grade 1, the difference between the total anticipated and total reported amounts of refrigerant must be less than or equal to 5%. And as we said earlier, a geotagged and stamped location photo needs to also be included. As with this method only said before, there is no grade 2 option. It either passes or fails. And then once it does that, this is the final step to be graded. And if you can't move on to the next one, corrections need to be made. Either refrigerant needs to be added and or taken out and adjusted for that part of it. As we see, if it's overcharged, you've got a problem of it not cooling. If it undercharges, it overcools, and possibility of freezing up the line set and or coil in the system. And so that's what you need to avoid. That's inefficiency. If the coil is getting too cold too fast and freezing too fast, then you're reducing airflow into the system. You're also ruining or messing up its humidity control in the system. So you now have inefficiencies in the system. Again, that's why we're doing a report card and we're doing grading of the installation, is to make sure that that's done correctly. So, and with
And
that, we go ahead.
oh, yeah,
Go ahead.
I just wanted to talk about the refrigerant grading section because it's the one that's caused probably the most issues in the rating community.
Yep.
Because a lot of people they're not just doing the ANSI 310 assessment to do the ANSI 310 assessment. They're doing it so that they're able to apply the grade 1, 2, and obviously hopefully not 3 to these different aspects of the system so that they can get additional points for things like Energy Star and so on and so forth, right? And the problem when it gets to the refrigerant is a lot of, unfortunately, it's somewhat common that they basically just rely on the HVAC contractor to do the weigh-in method, but then they fail to do all the additional things. So like Randy was talking about measuring the line set and the length of it and measuring the diameter, right, of it. Those all actually go into equations that are described in ANSI 310. And so at the end, you get this weight deviation value that you then enter into the software tool to determine these additional impacts that you might get on your ERI or HERS index. And unfortunately, a lot of people I've noticed they get that weight draw or they get that weigh-in and they get that picture and they say, all right, well, we didn't add anything, or maybe we added a couple extra, we took away a couple ounces, whatever it may be. And that's it for them. And then they just put in a number into the software tool to make it say grade 1 because we did the weigh-in method. but they just are ignorant of the fact that, hey, you actually have to do math. Um, some software tools like HouseRater actually have this baked in there to where you actually have to put in the values for each of these things before you even get a grade 1, 2, or obviously in refrigerant, grade 1 or grade 3. Other tools that basically just wait for that final output of whatever that weight deviation value is. And so they're relying on the rater to know to do that math and not just type in a number until you get grade 1. And so this is another caution I would have for code officials if you're getting documents from a rater saying, hey, we're doing ANSI 310, we're doing the ERI compliance path, we're doing Energy Star compliance path, whatever it may be. When it gets to the refrigerant, make sure you have some kind of proof that someone measured the length of the line set, someone's got the required measurements, and that the math is done. There are some speed sheets and whatnot that have been produced that are publicly available in the rating community. So there's not an excuse at this point in time, but at the same time, right, there's just a lot of people have been, yeah, they weighed in the refrigerant, we're good to go. I'm going to type in a number like 5 or something like that in the software, and I've got grade 1, I'm good to go. That's not the case. So do be careful if you have people doing this because, yeah, the refrigerant charge section is the one that causes the most concern because it's a lot of work to do the non-invasive method. So everyone prefers to have push it off onto the HVAC contractor for obvious reasons.
Yep.
And so that has caused some people to forget, no, you're actually responsible for these additional measurements. And it's only like 2 or 3 equations that you actually have to do. And if you're using one of these spreadsheet calculators, like I mentioned, or you have a software tool like HouseRater that does it natively, it's not an issue, but that's not the case for everyone. And so it has caused issues in the rating community. I can tell you that right now.
Yeah, those third parties that's moved to digital platforms, like either they build their own or they're using something like HouseRater, they'll have those equations in there that can just be typed in a few numbers. It does the calculations for you. If someone's out there still doing stuff by paper, it is a lot of work. And you if you don't have an Excel spreadsheet or an iPad or a laptop or something that has an Excel spreadsheet on it that you can have the equations in there, you got to find a way to do it. Either that or you're going back to your office before you can verify this. You have to go back to your office and complete all this. And if it fails, then you're going back out there to get some corrections done and or having it retested. So that was a great point, Connor. I appreciate that. So once we've made it through step 5, the HVAC system is hopefully given a grade 1. And so with this achievement, we've confirmed that the system is operating at its peak level of performance and efficiency, aka we got what we paid for. The system is installed correctly per code requirements, per manufacturer's instructions. And so this does ensure that the system will last longer, the occupants are more comfortable, and best of all, less energy is being consumed for conditioning and humidity control as well. And then last thing that I'll say with this part of it is we've covered the fundamentals for HVAC and the best practices for implementation. As HVAC performance evaluation continues to evolve, standards like ANSI 310 play a critical role in ensuring energy efficient in code and high performing built homes. So I encourage you to apply what you've learned here today in your inspections, your energy modeling, your plan reviews, and HVAC assessments. Let's continue to work together to improve the energy efficiency and building performance through better HVAC installation. When I say better, that just means it's meeting what the instructor and the manufacturers has told us it was going to be. So I thank everybody for joining us today. Please join us for our next webinar. Connor, thank you so much for being here with me and being a guardrail and some technical advisor for that. I appreciate you joining us. Our next one we have coming up is blower door testing and its impact on HVAC sizing. So you saw the newsletter that came out today. We strategically dropped that right before we do a webinar, and then it should have the next webinar that's coming up. As you can read through that, it's basically ensuring that, yeah, when you do blower door testing, and as we said earlier, if they use leaky, then that changes its load calculation. So that has an impact on HVAC sizing, and we'll go through a little bit of that. And then here's my contact information. Feel free to snap a picture of this, save it to your phone, whatever you need to do, and just share this as much as you liked with other people so I can help them with energy code or just questions with compliance and enforcement. Thanks for the hands claps and the thumbs up. I really do appreciate it. Thanks to everybody for being here today. And lastly, connect with us. We are on LinkedIn, we are on X, and we are also now on Blue Sky. And here is our social stuff that you can find us on and join us on those platforms. Especially for LinkedIn, there's a lot of announcements that come out for LinkedIn. So we appreciate everybody being on LinkedIn with us as well as on X.